Before listening to this video, sorry in advance if ang audio is diligid kay klaro kay natimingan nga nagulan pag-record na ako. I hope you can understand. Thank you. So, good day. Our report is about forms, scaffolding, and staging. So, first is, what is forms? Forms are a temporary boarding sheet or pan used to produce the desired shape and size of concrete. It should be watertight, rigid, and strong enough to sustain the weight of fresh concrete. Must be simple and economical, designed in such a manner that they are easily removed and reassembled without damage to themselves or to the concrete. So, si forms is kana to makita nga before mabuhusan ang atuang beam, like ang skeleton sa atuang beam or sa atuang girders or sa atuang columns, but nga na siya forms which would serve as a mura siya mold kibali nga murag mo'y magpatabang nga makakreate o shape ang atuang example atong beam or column. So, our forms are selected based on the cost of materials, construction and assembling cost, the number of times it could be used, the strength and resistance to pressure, and tear and wear. So, forms are classified into 7. First is as to materials. It could be wood, metal, plastic, or composite. And as for its shape, it could be straight or circular. It could be solid or hollow cast, which could be single or double. And as to methods of construction, it could be ordinary or in unit. And as to its uses, it could be used sa foundation, walls, steps, beam, and girders, slab, and sidewalks, and etc. And si forms sa pag-construct sa iya, consists siya of retaining board, supports and studs, braces and spacers, tire wire, and baits and nails. So, for the types of post and wall form, it could be continuous, whole unit, layer unit, which could be continuous or in sections. So, before na to magamit si forms, dapat siya i-grease. So, greasing is used so that ang atuang wood ma-waterproof na makaprevent siya in which could cause swelling or warping na gikan sa concrete, like especially pag magbuhos na. So it could also prevent the adherence of concrete into the pores of the wood. So ang common ginagamit as a grease is crude oil. So si crude oil is the most economical and satisfactory materials for this purpose. So si crude oil is mixan din siya og number 40 motor oil to a portion of 1:3 mixture or with varying viscosity depending upon the temperature of condition. So, if gusto kang a thicker mixture, especially recommended siya pag warm ang weather, greasing of forms should not be allowed after the steel bars have been set to its position. So, metal forms also need oil application to prevent rust formation. So, atong forms, common good yung ginagamit is plywood. So, si plywood is versatile construction material used as a wall partitions, cabinets, furnitures, but plywood could also be used as a form for reinforced concrete construction partitions. So, advantages niya, it is very economical in terms of labor cost. It is lightweight and handy. It has smooth surface which may not require plastering. Less consumption of nails. Ease of assembling and disassembling, and it is always available. Like, biskan makakita yung plywood. So, si forms can be square, rectangular, or circular. So, for the forms, for square and rectangular column, we can determine the materials for it. We must consider the following. So the thickness of the board to be used, the size of the frame, and the types of framework to be adopted, which could be continuous rib type or stud type. Ano siya nga, continuous rib type and stud type. So, sa pag-identify nimo kung pila ka forms imuhang magamit, you should follow 4 steps. So, first, formula in finding the materials for square and rectangular column forms. So, mag-follow to 4 steps. First is to identify the lateral perimeter of the column. So, si letter P, equal siya sa 2 times the shorter side of the column. It's either paanak or paanak. So, ang shorter side of the column and the longer side of the column. And si plus 0.20 is a constant. It is a constant value for the lapping of formula. So after we can identify the lateral perimeter of our column, so we will be multiplying it by the height of the column times the number of columns to get the total area of the forms. So once makuha na itong P, ato din siya i-multiply sa height at i-multiply din nato siya sa number of columns. And after makuha na nato ang total area of the columns, of the forms, so we will divide the area nga ato nakuha by 2.88 to get the number of plywood forms nga dapat nato gamiton. And after that, the number of plywood found by 29 So, ang atong value nga nakuha ganina nga atong i-divide og 2.88 ang area. Ato din to siyang i-multiply by 29.67 to get the board foot of frame required. So, to visualize more ani nga step, so na example. So, for example, 1. 6 concrete posts at 4 meters high with a uniform cross-sectional at dimensions of 0.30 by 0.30 meters. Specify the use of 6 mm or 1/4 inch marine plywood on a 2x2 wood frame. List down the materials required using a continuous rib type. So, muni ato ang A, muni ato ang B, and muni siya ang forma sa continuous rib type. So, for the solution, first is to find the lateral perimeter, which is P is equals to 2 times 0.30 plus 0.30 plus 0.20. So, natay makuha nga 1.40 meters. After that, 1.40 meters will be multiplied by the height of the column and kung pila ka columns ang ato ang gamiton. So, A is, in this example, A is equal to 33.8 square meters. And after that, after obtaining the total area of the columns, ato din siya i-divide by 2.88. So, makakuha din tag 11.7. And since wala man tayo 11.7 number of plywood, so dapat nato siya i-round off. So, dili magid malikayat nga we would aim nga dili lang rectangular or square ato ang column to give an aesthetic look sa ato ang building. So, nagi circular columns. So, si circular columns, plain galvanized iron sheet and black sheets are commonly used as sheeting for circular, oval, elliptical, and other circular types, considering its versatility in forming any shape of geometrical design. So, si metal sheet form, it is supported by metal frame or either plain bars, angular, T, or circular cross-section or whatever is specified in the plan. So, in estimating kung pila ang ato ang magamit, so we will also follow 4 steps. So, first is to find the circumferential area of the circular column using the formula C is equals to pi times the diameter times the height times the number of columns. So, after makuha na to ato ang circumferential area, ato na siyang i-divide by the covering of one metal sheet, which is provided siya sa table later sa example. And for number 3 is to count the number of ribs or support classified as to their kind and length, then cut board foot. And if thicker plywood board will be used as form, the spacing of the frame could be increased, reducing its board foot by 20% to 30%. So, dili magid malikayat nga we would aim nga dili lang rectangular or square ato ang column to give an aesthetic look sa ato ang building. So nagi circular columns. So si circular columns, plain galvanized iron sheet and black sheets are commonly used as sheeting for circular, oval, elliptical, and other circular types, considering its versatility in forming any shape of geometrical design. So, si metal sheet form, it is supported by metal frame or either plain bars, angularity, or circular cross section, or whatever is specified in the plan. So, in estimating kung pila ang ato ang magamit, so we will also follow 4 steps. So first is to find the circumferential area of the circular column using the formula C is equals to pi times the diameter times the height times the number of columns. So after makuha na to ato ang circumferential area, ato na siyang i-divide by the covering of one metal sheet, which is provided siya sa table later sa example. And for number 3 is to count the number of ribs or support classified as to their kind and length, then convert to commercial size of steel bars. And lastly is to in estimating materials for any particular work, a detailed plan is imperative. Without a detailed plan, except a haphazard result even from your biggest estimator. So, as an example, from figure 5.4, determine the required metal black sheet from 8 circular columns 4 meters high each with a uniform cross-sectional diameter of 60 centimeters. So, first is to identify the circumferential area. So, C is equals to pi times the height times the diameter of the column times the height and times the number of columns. So first, C is equals to pi times 0.60, which is equal to 1.88 meters, times the area, which is 1.88, which is C, times 4, which is equals to 7.52 square meters. So mo na to ang area for one column height and the circumferential of one column. So after identifying the area, we must find the area of the 8 columns by multiplying the area of one column by 8 kay mo man ato ang required, which is 8 circular columns. So we have a 60.16 square meter as a total surface area. After we must find the number of sheet required, which is mag-refer ta diri sa table number 2 diri. Using a 1.2 by 2.4 meters black sheet, so we will multiply 0.347. So, naatay 20.66 and wala may wala may bars nga kaning dili whole number. So, dapat na to siya i-convert, which is 21 pieces. So, after that, we must find the number of vertical ribs at 15 centimeters spacing distance. Nga mag-refer yapon ta sa table 5.52. So, vertical support is equals to 60.16 times 25, which is equals to 1,540 meters. So, convert the commercial length of steel bars, say 6 meters, long. So we will divide 1,540 over 6 meters. So we will have 250.667, which is converted or rounded off into 261 pieces. So after that, solve the circumferential ties referring again to table 5.2. So si ties is equals to 60.16 times 9.54, which is equal to 572.7 rounded off into 573 meters. And after that, we will convert the commercial length of the seal bars by 6 meters. So 573 meters na ties over 6 is equals to 95.5 or 96 pieces. So, sa atong forms, naaman yun si beams and girders. So, there is a different way in finding the materials for beams and girders. Because, see, beams and girders are made only by 3 parts. 1 bottom form and 2 side forms. It may be either metal or plywood materials supported by galvanized pipe staging or wooden lumber of varying materials, varying sizes from 2x2 to 2x3 frames. When coconut lumber is used, a bigger size from a 2x3 to 2x4 are used. So, as I've mentioned, there is a different formula in finding the materials for beam and girder form. So, we will also follow 4 steps. So, first is to get the perimeter of 2 sides form, which is equal to 2 times the 2 side forms, measurements of 2 side forms, plus the bottom form, plus the 0.10 constant value for the lapping of forms. Then after obtaining the perimeter of 2 side forms, we will multiply it by the length and number of beams to get the total area of the forms. Then divide it by 2.88 to get the number of plywood forms. And then multiply the number of plywood found by 22 to get the board foot of frame required. So, example, 10 concrete beams with cross-sectional dimensions of 0.30 by 0.60 meter has a uniform clear span of 4.50 meters. Using 1/4 inch or 4 by 8 plywood form on 2x2 lumber frame, list down the materials used. So first is to find the plywood form. So in finding the plywood form, first we must identify the lateral perimeter of the beam, which is equal to 2 times 0.60 plus 0.30 plus 0.10, which is equals to 1.60 meters na lateral perimeter of the beam. After that, we will multiply our P by the number of beams to get the area of the form. So 1.60 times 4.50 times 10 columns is equal to an area of 72 square meters. Sa area then, ato siyang i-divide by 2.88 to get the number of plywood required. So, number of plywood is equals to 72 over 2.88, which is exactly 25 pieces. After that, we will solve for the 2x2 wood frame na require sa given. So, we will refer to table 5.1. Using under column beam using a 6 mm 1/4 thick plywood on 2x2 frame, we multiply 25 plus times 25.06, which is equals to 626 board foot. And so, para ma-identify na to kung pila gid ang atong i-order, so we multiply 25 pieces na 1/4 times 4 by 8 plywood form, which is equals to 626 board foot 2x2 lumber. So, and for the last example, 10 concrete girder with the general dimensions of 0.35 times 0.50 meter has a uniform clear span of 6 meters. So if 12 millimeter marine plywood will be used on a 2x3 lumber, find the materials required. So just following the procedure, ma-acquire tani nga mga values. So to practice, just run through the discuss examples, makuha siya. Thank you.
Scaffolding and staging. Why do we need to install scaffolding and staging? Or what are the reasons why the construction industry uses scaffolding? It is to ensure safety. Safety is topmost priority at construction sites. Using scaffolding, therefore, becomes important for creating a secure workplace for workers who work at heights during the construction of a building. Another advantage of using scaffolding is that it provides a flat and balanced working platform that allows multiple workers to work on a site simultaneously. This really helps in the speedy construction of different structures. Maintaining balance for workers become easier with scaffolding equipment, so the chances of unwarranted accidents goes down. Scaffold also requires handrails on the top platform, reducing the chances of injury. These are also important for the safety of pedestrians and public. Second is easy access. The construction of high-rise buildings is a difficult task because there are many parts to a building, which are difficult to reach for workers because of their position. Scaffolding solves this major problem and workers can focus on their work without any difficulty. They can reach any part of the wall or ceiling of a building within arm's length. As a small platform of wood, fiberglass, or lightweight metal, it offers the much needed height to finish a task easily and efficiently. Third reason is position advantage. A big advantage of scaffolding is the strategic position it provides to workers. Though ladders are also used for this purpose, they are mounted at an angle and they don't offer a solid platform that workers can balance. Scaffolding puts workers directly in front of the portions of the wall or ceiling where they need to work. This provides them great leverage. If multiple workers are required to work simultaneously, side by side, that's not possible using ladders. So, scaffolding is a temporary structure of wooden poles and planks, providing platforms for workers to stand on while erecting or repairing a building. It's further defined as a temporary framework for other purposes. While staging is a more substantial framework progressively built up as tall building rises up. The term staging is applied because it is built up in stages one story at a time. So, scaffolding is used as a platform for workers while staging supports the structure when the concrete is not yet solid. Different parts of scaffolding to consider are vertical support, base of vertical support as needed, horizontal member, diagonal braces, block and wedges, nails or bolts. Parts of scaffolding. So this is the vertical support, and this is the diagonal braces and horizontal support. This is also base of vertical support, blocks and wedges, and nails or bolts. Common type of scaffolding: single scaffolding or brick layer scaffolding. It is mostly employed in brick masonry. In this type of scaffolding, a series of vertical members made of bamboo or timber named as standards are firmly fixed into the ground in a row parallel to the building wall. The second one is the double scaffolding or mason scaffolding. In case of brick layer scaffolding, single row of standard is fixed into the ground. But in the case of mason scaffolding, two rows of standards are fixed into the ground. First row of standards is fixed close to the wall, and second row of standard is fixed at a distance of 1.5 meter from the first row. This is why it is named as double scaffolding. In the case of brick layer scaffolding, one end of both logs is fixed with wall. But in double scaffolding, put logs are not fixed with the wall. Put logs are supported at both ends on ledgers. Therefore, mason scaffolding is completely independent of the wall surface, and there is no need to make any hole on the wall surface. The third one is the steel or tubular scaffolding. The method of construction of steel scaffolding is similar to that of bricklayers and mason scaffolding. The primary differences are, instead of using timber, steel tube of diameter of 40 mm to 60 mm are used. Instead of using rope lashing, special types of steel couples are used for fastening. And instead of fixing the standards into the ground, it is placed on base plate. So, the advantages of the steel scaffolds are it can be erected or dismantled more rapidly in comparison to simple scaffolding. This helps in saving construction time. It is also more durable than timber, therefore it is economical in the long run. It has more fire-resisting capacity and more suitable and safe to work at any height. The fourth one is the needle scaffolding or cantilever scaffolding. Needle scaffolding or cantilever scaffolding is required when it is not possible to fix standard into the ground, and when construction is done on the side of a busy street, and when construction work is carried out at a very high level in case of tall building. In this type of scaffolding, instead of fixing the standard into the ground, it is placed at some height above the ground level. The platform on which stands are placed is called needle. A needle is a cantilever structure made of timber projected out from the holes in the wall.
Estimating scaffolding and staging. Estimating the materials for scaffolding and staging requires time and wider imagination, considering the different parts of the structure involved, such as the vertical and horizontal supports, the diagonal braces, plus the blocks and wedges, which are not shown on the dated plan of the building. The common practice of most estimators is to make an estimate of this item by either by quantity of the materials or by lump sum amount in the bill of materials and cost estimate. So, on estimating the scaffolding and staging, we will provide a sample problem. In this problem, a reinforced concrete building has 9 columns with a clear height of 4 meters as shown on the figure. Determine the required scaffolding under the following specifications of 2-inch by 3-inch vertical support and 2-inch by 2-inch horizontal and diagonal braces. So we are going to use this table 5-3, quantity of lumber for scaffolding or staging. So we have the lumber size, the values that we need to get in finding the quantities that we need. So we have different values for columns, used for beams, for floorings. So first, in the solution, on finding the scaffolding for columns, we first need to find the total length of the columns. So here in the problem, we have 9 columns all in all. So in finding the total length of the columns, so given naman na we have 4 meter height sa mga columns, so we only need to multiply it by 9. So 4 times 9, we have 36 meters for the total length of the columns. So by referring to the table 5-3 using 2-inch by 3-inch vertical support, we are going to multiply 36 meter by 7. So 7 can be found here in the table for column, so vertical column man daw, so vertical support man daw, so we need to locate 2 inch by 3 inch in the vertical of the column. So we have a value of 7. So 36 by times 7 is equals to 252 board feet of the lumber of 2 inch by 3 inch. So for the horizontal supports, using 2 inch by 2 inch lumber, so we also need to multiply the 36 meters by 21 found in table 5-3. So 36 times 21 is equals to 756 board feet of 2 inch by 2 inch lumber. For the diagonal braces of the columns, scaffolding for columns, we need to multiply 36 by 11.7. So we have 421 board feet of 2 inch by 2 inch lumber. For the scaffolding for the beam, same, we need to find the total length of the beams. So the length of the beams, so we have 6 beams all in all. That 6 beams with a length of 4.50 and 4.50 meter and 4 meter. So 4.50 times 6 plus 4 times 6 is equals to 51 meter all in all. Then referring again to the table 5-3, the vertical support that will be used is solved by multiplying 51 meter by 6 is equals to 306 board feet of 2 inch by 3 inch. For horizontal support 2 inch by 2 inch lumber, we need to multiply 51 by 4.7, which is 240 board feet 2 inch by 2 inch lumber. For the scaffolding for concrete slab, we need to find the area of the concrete for slab. So the area as shown in the figure, we have 4 units of we have 4 slabs all in all with a length and a width of 4 and 4.5 meter. So we only need to multiply all of the values 4.5 times 4, and there are 4 units times 4 is equals to 72 square meter. So by referring to table 5-3, using 2 inch by 3 inch support, we need to multiply 72 by 9.10. So we have 655 board feet. For the floor slab forms, so we also need to find the floor slab forms. We need to use the area of the floor. So we already get the area of the floor, which is 72 square meter. So by dividing it by 2.88 effective covering of 1 plywood, we have 25 pieces. So this 2.88 has already been discussed na ni Ara. So 72 divide 2.88, we have 25 pieces of 4 feet by 8 feet marine plywood. So it is for the marine plywood, 2.88. So in summary, all in all, the materials needed for columns, beams, slab. For columns, we need 252 board feet of 2 inch by 3 inch and 1,177 board feet of 2 inch by 2 inch. For beams, we need 306 board feet of 2 inch by 3 inch and 240 board feet of 2 inch by 2 inch. For the floor slab, the concrete slab, we have 655 board feet of 2 inch by 3 inch. For the floor slab form, we need to use 25 pieces of 4 feet by 8 feet plywood. So, for factors that affect the percentage of waste of forms of scaffolding. So, in construction of multi-story building, transfer of forms and scaffolding from one floor to the next is an inevitable normal operation wherein wastage of materials cannot be avoided due to tear and wear. So thus, percentage of waste varies depending upon the following factors. So the difference, first is the difference in height between floors may require adjustment of the forms and vertical support. Second is the difference in sizes of beams and girders also requires adjustments of the forms. Third is the major causes of forms and scaffolding tear and wear are the dismantling, transferring, and reassembling operations. Reckless use and handling of the materials includes the making of firewood and pilferages during period of construction. And lastly, the use of inferior quality lumber contribute to the high percentage of waste and risk of the workers. So next is the steel pipe scaffoldings. So the steel pipe scaffoldings can be used freely to prefabricate height and width according to the laces and forms to install. Galvanized steel pipe with good strength makes durability and also leads economical delivery and storage. Standard scaffolding frames have a 4 feet or 1.20 meter width available in 3 different heights ranging from 0.9 meter to 1.70 meter. So they are useful for access platforms and concrete support works. So for the steel pipe scaffoldings, we have the adjustable base jack, adjustable U-head, we have the adjustable double prop, the adjustable straight prop, and the inner pipe, which will be inserted at the top. Then we also have cross braces, which is used in the columns, a joint pin, and the adjustable slab barrier. And that would be all. Thank you.